So, take a quick second and just think about the ground you're standing on right now. It feels pretty permanent, doesn't it? Like it's perfectly solid, totally stable, and just completely still. But what if I told you that everything you think you know about the stability of the Earth is, well, kind of an illusion? The awe-inspiring truth is that our seemingly solid ground is actually a fragmented shell made up of massive puzzle pieces, and they are in constant, relentless motion.
Welcome to this explainer. I am absolutely thrilled to guide you through this fascinating material today, focusing completely on Lesson 6.4. We're going to embark on an exploration into the incredible invisible forces that dictate the very shape of our entire planet. We're talking about the powerful mechanisms responsible for the most dramatic landscapes and the most terrifying natural events we ever experience.
Here's a quick roadmap of what we'll cover. First, the engine of geological change. Second, the making of fold mountains. Third, volcanoes and eruptions from below. Fourth, earthquakes, friction, and faults. And finally, modeling tectonic plate movement.
All right, let's jump right into part 1, the engine of geological change.
Okay, take a look at the red line outlining the Pacific Ocean on this map. You've probably heard of it. It's often called the Pacific Ring of Fire. Now, what's really fascinating here is that major geological events, things like massive volcanic eruptions and earthquakes, they all cluster right along these very lines. This teaches us something absolutely vital. These massive geological events aren't just random. No way. They happen in very specific, highly active zones.
So what exactly are these highly active zones? Well, they're called plate boundaries. You see, the Earth's crust is made up of huge tectonic plates, and plate boundaries are simply the edges where these massive plates meet up. Because these plates are literally always moving, these boundaries are the primary sites where the Earth transforms. And here's the crazy part. Sometimes that change takes millions of years, and sometimes it is devastatingly sudden.
Which brings us perfectly to part 2, the making of fold mountains.
So when tectonic plates move together and collide, a few things can happen. One major process is called subduction. Basically, one plate is forced to literally slide right underneath the other one. As the rock from that bottom subducting plate gets pushed deeper and deeper down into the Earth, the extreme heat causes it to melt right into the mantle, becoming a part of it. It's essentially this massive planetary recycling system for the Earth's crust.
But wait, sometimes when these massive plates move together, they don't slide under. Instead, the rock layers compress, crumple, and fold straight upwards. And bam! That exact buckling process is what creates fold mountains, like the stunning Himalayas. What's completely mind-blowing here is the sheer scale of deep geological time. I mean, the newest fold mountains, like the Himalayas in Asia or the Rocky Mountains in North America, they're considered young in geological terms, but they still took between 10 and 25 million years to crumple upwards. Contrast that with the oldest fold mountains, like the Ural Mountains in Russia. Those are over 200 million years old.
All right, moving on to part 3. Volcanoes, eruptions from below.
We just talked about plates crashing, but what about when tectonic plates drift apart from each other? Well, when that happens, they break and crack. And this cracking crust gives extremely hot liquid rock from the mantle, which we call magma, a clear path to rise right up. Once this glowing liquid rock actually erupts onto the Earth's surface, it gets a new name, lava. As that lava eventually cools down, it hardens to form brand new crust and new rocks, slowly, layer by layer, building a volcano over time.
If we look inside, deep underground sits this massive chamber of magma. Tremendous pressure forces this liquid rock up through the central pipe, which is known as the main vent. It can even branch off into secondary vents along the sides. Finally, it explosively exits through the crater at the top, blasting layers of ash and lava onto the surface and sending these massive, dark ash clouds way up into the sky.
Now, you don't need to panic because not all volcanoes pose an immediate threat. Scientists actually categorize them into 3 types to help us understand their life cycle. Active volcanoes are exactly what they sound like. They're alive and they may erupt at any time. Then we have dormant volcanoes. These are essentially sleeping. They haven't erupted for a really long time, but there's still a possibility they could wake up one day. And finally, extinct volcanoes are dead. The geological engine beneath them has completely shut down and they will not erupt again.
But when an active volcano does erupt violently, like Anak Krakatau over in Indonesia, which you can see right here, the consequences are staggering. If the magma is really thick and contains a lot of dissolved gas, the pressure just builds and builds to extreme levels.
When it finally gives way, gases and rocks shoot up with terrifying violence. In the case of Anak Krakatau, a powerful eruption blew a huge part of the volcano right off into the sea. These types of violent eruptions can trigger massive avalanches, severe earthquakes, and even devastating tsunamis if the volcano happens to be close to the ocean.
Let's look at another consequence in Part 4, earthquakes, friction, and faults. Okay, so what happens when these giant plates try to just slide right past one another? Well, as you can probably imagine, they don't exactly glide smoothly. Because these slabs of rock are so incredibly large and heavy, there is an immense amount of friction between them. Over the years, these jagged plates literally snag and stick together. But remember, the engine driving them never stops pulling, so the pressure silently and continuously builds and builds and builds.
And honestly, the contrast here is terrifying. You've got this slow, silent buildup of pressure for years, ending in a violent, sudden release. When that friction is finally overcome, the plates just snap past each other. That sudden, violent movement is an earthquake, and it's absolutely capable of shredding solid infrastructure, like the road you see here. The size or the magnitude of an earthquake depends on the size of the faults at the plate boundaries and just how far those rocks move. In the absolute largest earthquakes, massive sections of rock can violently shift tens of meters in mere seconds. It's wild.
So, how do we wrap our heads around this scale? That's Part 5, Modeling Tectonic Plate Movement. You might be surprised to learn that we can actually visualize these epic, planet-sized events using totally simple, everyday items. It's true. For instance, if you take a piece of cloth, lay it flat, and slowly push the ends together, it buckles upward. That perfectly mimics the slow, crumpling rise of fold mountains, like the Himalayas. If you take two pieces of paper and slide them past each other while pushing them together, you can actually feel them catch and stick. That beautifully models the sticking friction that eventually snaps and causes earthquakes. And pushing two soft-centered chocolate bars together, that perfectly visualizes what happens when the Earth's crust collides and deforms.
So, as we wrap up our explainers today, this is the absolute core takeaway I want you to remember. The beauty and the terror of our planet's surface are completely intertwined. One unified geological engine, the continuous movement of tectonic plates at their boundaries, drives everything. It is entirely responsible for both the agonizingly slow, multi-million-year rise of the highest mountain peaks and the terrifying split-second violence of volcanic eruptions and earthquakes.
Which leaves us with this one final thought. We know for a fact that tectonic plates are always moving. The engine literally never, ever stops. So the next time you step outside and look at the solid ground, ask yourself, what immense pressures and invisible changes are silently building right beneath your feet, just waiting for their moment to break the surface? Thank you so much for joining me for this explainer. Keep questioning the world around you and keep learning.